Uh, Warm good morning to all of you. Hopefully, audio video is okay. Anyone, please reply. Not- No one is a speaker, mic.
Yes, sir, you're audible.
Yeah, thank you for reply. So last time we were doing how to generate the scheme or how to generate the continuous variate, right? For the simulation purpose. So in continuation of that, let us have another question. It is very good question. Describe how to generate random variate from the PDF fx is equal to mod of x for the range -1 to 1 and elsewhere it is 0. So and this question is also from your book. So here we have, so it is given to you fx is equal to mod of x for the range from -1 to 1 and elsewhere it is 0. So first we have to compute in such question. First we have to compute the CDF. So before computing a CDF, fx can be written as minus x for the range -1 to 0, x for 0 to 1 and 0 elsewhere. So when we compute the fx, so fx is what? General formula is minus infinity to x fx into dx. So if we have to compute for the range x less than -1, so it will be the minus infinity to x 0 dx, so it will be the 0. If x lie between -1 to 0, so it will become minus infinity to -1 0 dx plus -1 to x, and in this integrand is the minus x. So here it will be the minus x into dx. So this will be the 0, because in this integrand is 0, plus here integration is the minus x square by 2 minus 1 to x. So this will give you 1 minus x square by 2. Now when we have the x is equal to 0, so this will give you fx will equal to the 1 by 2. When x greater than 0 but less than 1, so this will become minus infinity to fx will become the minus infinity to 0 plus 0 to x into, and here we have the integrand x and dx. So for this we have computed as a half. In general, common mistake we have seen, you do not add the here the half. So half, and here integration is the x square by 2 0 to x. So this will give you 1 plus x square by 2. So now when x is equal to 1, at that time fx will become, it is 1. So when x x is greater than 1, so fx will be minus infinity to 1 plus 1 to x. So its value is 1 plus 1 to x 0 dx, because elsewhere PDF is 0. So this will give you 1 plus 0, that is equal to 1. So if you write the fx in the fair form, so always there must be 0 and 1. Here the range is less than minus 1. Here the range is greater than 1. Then after greater than equal to 1, then after so from here you can see it range from minus infinity to infinity. And for the minus 1 to 0, we have computed the fx as 1 minus x square by 2. So 1 minus x square by 2, and for the range 0 to x to 1, it is the 1 plus x square by 2. So in this way we can compute the CDF. And in general, for computing the scheme, we equate the fx with the uniformly distributed number between 0 and 1. So what we have to do, 0 to 1, it range from 0 to 1 fx. You also range from 0 to 1, means 0 is equal to 0, 1 is equal to 1. And here in between we have computed one constant. So the same constant we have to consider for the u. In this, here we have the intermediate value 1 minus x square by 2, 1 plus x square by 2. So here we assume that here intermediate value is u, here the intermediate value is u. So when we do 1 minus x square by 2 is equal to u, and 1 plus x square by 2 is equal to u. So this will give you x square is equal to 1 minus 2u, x is equal to plus minus root of 1 minus 2u. And here the x square is equal to 2u minus 1. So x is equal to root of 2u minus 1. But we have seen, we have the PDF here, the PDF is in PDF x is negative also from minus 1 to 0. So from there we have to take x is equal to minus of 1 minus 2u, and here we have the x positive, so root of the 2u minus 1, where u is from the 0 to 0.50, and here the u from 0.50 to 1. So always you have to take the equality on the left side only, left side of the inequality. You have to take the sign of the is equal to. Clear? So here x will become minus 1 minus 2u and root of 2u minus 1 for the range 0 to 0.50 and 0.50 to 1. So in this way we can generate the x following the following the this given distribution. So this we have computed, right? So this scheme we have computed. Now generation of the Poisson distribution. So Poisson distribution, you have the idea what is the Poisson distribution in this, uh, because Poisson distribution is also important. So how we can generate the Poisson distribution? So what is the main characteristic of the Poisson distribution? In the continuous time, we have the occurrence of the rare event, occurrence of rare event, right? In the Poisson distribution, we have the occurrence of the rare event, and this is nothing. This is the Poisson process also. So the Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time and or space. Space means, for example, in the room, if we want to count how many bacteria, how many viruses we have in the particular room, so it is the number discrete events in continuous volume space. How many bacteria we have on the plate? So number of bacteria, discrete events in a continuous surface area occur with a known average rate and independently of the time since the last event. So suppose the event occur in a Poisson process at a mean rate alpha. So mean rate is given to you alpha. Let x be number of occurrences of a event in an interval 0 to t, where t is so chosen that alpha t is equal to mu. Means alpha is what? Alpha is what? Alpha is the average rate. Alpha is mean rate. Means in unit time how many occurrences we have. Now if we are talking for the duration t, for the time interval 0 to t, so on an average how many occurrences can occur? So alpha into t, number mean number of occurrences in interval 0 to t, in interval 0 to t, and we denote it by the mu. So when we denote it by mu, so here where t is so chosen that alpha t is equal to mu, where mu is the parameter. So x has the Poisson distribution with parameter mu. Let t1 is the time that elapses first occurrence until the first occurrence of the event, and uh, ti be the time that elapses after the I minus 1th occurrence and up to the ith occurrence. I is equal to 2, 3 and so on are the independent exponential variate. So we know that when the occurrences are when the events are occurring in a Poisson process, so inter occurrence time follow the exponential distribution. So let us say this time is the t1, this time is t2, this time is t3, this time is t4, like this. So means the time elapsed after the occurrence of the previous event. And here x denote xt or x denote number of occurrences in interval 0 to t, in interval 0 to t. So and x has the Poisson distribution with parameter this. So and here the ti follows the exponential distribution with parameter alpha. Thus the x satisfy the inequality. So here this x satisfy the following inequality: t1 plus t2 plus tx. Tx means number of occurrences. X is the number of occurrences. So whatever the occurrences we are talking. So here the t1 means what we are saying here. Let's say this is the t, and here we have the occurrences. Here we have the occurrences. So what is this? This is the t3, and here we have the t4. T4. Here we have the t2. Here we have the t1. So naturally, t1 plus t2 plus t3 less than t less than t1 plus t2 plus t3 plus T4. So if we are talking for the third event, so we can write in this way. So T1 plus T2 plus Tx less than equal to T less than T1 plus T2 plus Tx plus Tx plus 1. So define the random variable ui. Now we are defining the new random number ui, random variable ui e to power minus alpha ti, where I vary from 1 to 3 to x plus 1. So in this case, if you define the new random variable, so let ui is equal to e to power minus ti, alpha ti, and ti is what? It is the exponential distribution, right? With parameter alpha, with parameter alpha. So ui is what? What is the distribution of the ui? Ui follow the uniform uniform distribution. Ui follow the uniform distribution. Why? When the what is the what is the fti? What is the fti? CDF of the exponential distribution, 1 minus e to power minus alpha ti, right? Alpha ti. So this can be written as 1 minus ui. So ft is what? Vary between the 0 and 1. It means this also vary between the 0 and 1. In last example, I have shown you that if 1 minus u follow the uniform distribution, it means ui also follow the uniform distribution. It implies that ui also follow the uniform distribution between the 0 and 1. So here the ui follow the, right, ui follow the uniform distribution. Now in this, if you in this if you multiply, in this if you multiply by the alpha, so what, minus alpha, so what it will give you? Minus alpha t1 plus or minus alpha t2 minus dash 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 minus alpha into tx. Due to the multiplication of the minus, it will become the sign of inequality will change. Minus alpha t, not greater than, just greater than minus alpha t1 minus alpha t2 minus alpha t x plus 1, tx plus 1. Now if you take the exponential of this, so it will become e to power minus alpha t1 minus alpha t2 minus alpha tx e to power minus alpha t, not is equal to e to power minus alpha t1 minus alpha t2 minus alpha t x plus 1. So that can be written as e to power minus alpha t1, e to power minus alpha t2, and e to power minus alpha tx greater than e to power minus alpha alpha t greater than e to power minus alpha t1, e to power minus alpha t2, e to power minus alpha t x plus 1. This can be written as u1, u2, ux greater than e to power minus mu, right? Minus alpha t can be written as mu, and u1, u2, ux plus 1. That is the product of ui from 0 to x, 1 to x greater than e to power minus mu greater than product from 1 to x plus 1 of ui. So this is the scheme with which you can generate the exponential variate. So let us understand the same thing with example. So here we have computed the scheme. So using the random number, or you can say one more thing, uh, let us denote the e to power minus mu as a. So we have this scheme like this. So in this case, x is equal to 0 when u1 is less than a, x is equal to 2 when a lie between the u1 and u1 into u2, x is equal to 2 when it lie between the u1 u2 and u1 u2 u3. So in this way we can generate what is the value of the exponential variate. So let us understand this example, means this concept with this example. Using the random number 0.692, 0.346, 0.140, generate one observation of Poisson random variable x with mean, right, with mean 3. So mean is given to you with mean, so directly you have the mu. So step 1, first we compute the a is equal to e to power minus mu. So e to power minus 3, so its value is the 0.0498. Then step 2, if the u1 is what, 0.692, this is the u1, this is u2, this is u3. So if the u1 greater than a is what, a we have computed as a 0.0498. So if the u1 greater than u2, uh, a, and u1 u2 will be the multiplication of 0.692 and 0.346, so it is equal to 0.2394. And what is the u1 u2 u3, means multiplication of these three, it is a 0.0335. So you can see with this scheme, with this scheme a is lying between, the u1 u2 u3 and u1 u2, this one, this one. So this will implies x is equal to 2. So this will give you x is equal to 2. Means what is this value? This value is the 0.0498. This value is 0.0335. No, this value is 0.0335, and this value is 2394. 2394. So this will give you x is equal to 2. So in this way we can generate the exponential Poisson variate. So let us have the example of supply chain management. So here we have the problem 9.19 from book only. The booking and deliveries of a truck company over 100 typical days were as follows. So in this case, we have the example of the transshipment, or you can say transportation. The booking and deliveries of a truck companies over 100 typical days are as follows. So number of units booked 300 on the 8 days, 350 over the 18 days, 400 unit booked over the 24 days. Similar data for the 450 and 500 are 38 and the 12 days. Similarly, number of trucks available. So here we have the 3, 4, 5, 6, 7 trucks available for 16 days, 36 days, 20 days, 16 days, and 12 days respectively. So this is the data for the 100 days, and this is also the data for the 100 days. So frequencies are given to you, right? Frequencies are given to you for the booking and the trucks available. Each truck makes one trip a day. That is the restriction. He can means truck cannot repeat, cannot take the more trip. Can deliver 100 units when fully loaded. So in one trip, he can transport only maximum 100 units. As many trucks as possible are loaded full each day. So whatever the number of trucks available, accordingly, whatever the number of booked item we have, so we can load the trucks fully. If units are left which cannot load a truck fully, but truck is available, if we have the more item and more truck, but that truck is not fully loaded, we can load partially only. So capacity is what, 100. If we have the less than 100 items, so we will upload and transport. So truck will be partially loaded and made to go on the trip. We will not wait for the complete load. Truck unused are turned away. If there is no booked item and trucks are available, then there is no use of that truck, and we will ask the truck driver to take the truck right back, and are not required to wait for the next day. Units in excess of total truck capacity are stored overnight and added to the next day's booking. If booking is more than the truck, if truck are more than the booking, then truck will go away back, right? But if bookings are more than the available truck, so we have to store that booked units over the night, and we will add those units on the next day booking also, so that on the next day we can transport them and add it to the next day's booking for delivery. Simulate simulate 10 days operation by the company and compute averages and other characteristic of use to the management. So you have to determine, you have to estimate different type of the averages, so that decision maker can take some appropriate decision about the supply, demand and supply. So let X denote unit books on a day. So what is this? This is the discrete random variable, right? X is what? It is the discrete random variable. Let Y denote number of available truck. Then the distribution of the this Y is also what? It is the discrete random variable. It denote the number of truck available, and X denote unit book. Their frequencies are given to you. So from the frequency, you can easily compute the point probability function or the probability mass function or the PDF. So because it is for the 100 days, so PDF will become, means here we have the fx. So fx is equal to 0.08, 0.18, just you divide by the 100. So 0.24, 0.38, 0.12. So corresponding fx will come, capital Fx means CDF. It is the CDF. So CDF will come 0.08, 0.26, just you have to add these two, 0.26, 0.50, 0.88, and 1. So it means, what is the scheme? Scheme will come 002, 07, 082, 25, 262 49 502 87 882 99. Never we will take the right hand limit. Always we take the is equal to on the left hand limit. So this will be the range for the random number. Similarly, for the number of trucks available, so number of trucks can be 3, 4, 5, 6, 7, and corresponding PDF FY will be the from the frequency table. You can easily write 0.16, 0.36, 0.20, 0.16, 0.12. So CDF you can write, uh, you can say it is the Y. So f of y is the 0.16, 0.16 plus 0.36, 0.52, 0.52 plus 0.20, 0.72, right? 0.72 plus 0.16, 0.88, and 0.88 plus 0.12, it is the 1. So range for generating the y will be become 00 to 15, 16251, 52271, 72287, and 88299. So this is the range for generating the number of trucks. Now, so this we have done, right? So we have written the range there only. We have written the range there only. So with here we have the scheme. Now, the following notation we will use to make the table. So it is useful to you to determine the important characteristic. Let RNV denote random number for unit book, NUB number of unit book, UDB undelivered day before, TND total number of delivered, RNT random number for truck available, NTA number of truck available, NTU number of full truck available, CTU capacity of the full truck, LPT load of potentially filled truck, not potentially, it is the partially filled truck, NUT number of unused truck, and NUS number of units stored overnight. So these notation you can make for your convenience, right? It is up to you how you are making. In general, in exam we will give these headings, so you have to use the table using these field. So this is the table. Now you have to simulate for the 10 days. So here anyone has the PDF of the this book? Any one of you has that PDF of the this book presently? Because I have heard some of you have taken the scan one. Anyone? Yes, please reply.
So you are asking about EDD notes?
Ha, EDD notes.
Yes, sir.
Uh, uh, can you show the table by sharing
The,
your screen? Can you show the table?
sir, can you? I don't know the page number. I'll just check. 1 second.
Pardon? What you're saying?
Sir, I'll check the page number and open it, sir.
It is the I think table 11 in appendix.
Just a minute.
I'm stopping the sharing. just for a moment. Actually, I have to explain few things there. So you please share because I haven't the PDF of this.
So would it be fine if I send the PDF to you so that you can check?
Okay, you sent me. Otherwise, I will display here. You send me
Okay, sir.
here.
Yes, sir. Sir, I've shared it, sir, via mail.
Okay, I'm checking. You have shared. Achha. Just wait a bit. Actually, it is downloading.
Sir, it's 237. So it's in page 237.
So this is the table 12, table of the random digit. So generally we give you the table, right? So from the table itself only you have to take the number. So what is the rule to take the number? So here we have the means we can choose any row, any column. So for a moment, or any page. We have the number of pages, so we can choose any number, any row, any page. So let's see, we are choosing the second page. So this is the second page. Now we are choosing the, let us say randomly I am choosing the 36th row, any column, any column. Let's say 1 2 3 4 5, I'm choosing the fifth column. Now from where I have to start? I want to start from here. So now if I have to take the 3 digit random number, so 3 digit random number I have to take 566, right? 566. Then we have the 000. Then we have 018. Then we have 743, right? Means this is the first, this is second, this is third, this is fourth, this is fifth, this is sixth, seventh, eighth, nine, then 10th, 11, 12, 13, 14, like this. So if you required more, by chance we have the this is the some number, then 2 from here, and one from the next page, one from the next page. Then you continue. So in this is the never ending table. This is the never ending table. So in whatever the question we are discussing, in this we are taking the random number for the booking on from the page A58. Just from somewhere you note down. So we are taking the random number from A58 and row number 11. Row number 11. So from where we are taking row number 11. So row number 11. So this is the row number 11. So random number, you have to take the 2 digit random number. So 2 digit random number will be the 11 80 55 0 31 39 80 82 77, because we have to take for the 10 days, we have to simulate for the 10 days. So here we have the up to the 3 2. So arbitrary, we have to choose any row, any column. So we will specify in the exam, in the open with exam, you have to take the random number from this row, this page. So what is the main characteristic in choosing the number? Never you have to repeat any number, never you have to skip any number. In continuous you have to take the numbers. Similarly, for the number of truck, if you take the number from the uh, if you take the number from the A59 page and row number 25 and column number 3. So here, so this is the row number 25, this is the column number 3. So random number will start from 2645, 2645 747774519243, right? So in this way, for the 10 days you have to take the number. Clear? Is there any doubt for selecting the number? 72 for the 10 days you have to select, so 72 also. So how to choose the random number? Is there any doubt? Hopefully it is clear. So random number for the truck, we have seen, we have taken the from the page A58 row number, from the page A58 row number 11, row number 11. Here the random number for the truck we have taken from the page A59, right? A59 row number 25, column number 3, column number 3. So if the random number we are taking as a 0.11, there we are taking the digit, here we are taking between the 0 and 1. So it, when it is the 0.11, so 0.11 from here, here I have written the scheme. So what is the scheme? 0.11, 0.11 lie between, there I have written, it is not saved. So it is the 00 to 07, 08 to 25, 26 to 49, 50 to 87, and 88 to 99. Here we have the 00 to 15, 16 to 51, 5271, 72 to 87, 88 to 99. So 1 lie between here. So it means total number of unit book will become the 350. 350. So here we have written the 350 because it is the day first. Day first, so there is no undelivered item. It is 0. So total number of item booked will become the 350. Now we are taking the truck for random number for the truck. We have taken the first as a 26. So 0.26 lie in this interval. So total number of truck will be the 4. So when the total number of truck available is 4, so it will become, here the total number of truck will be the 4. So NTU, NTU means number of full truck, number of full truck. So with the 300 item, with the 300 item, right? You fill the 3 truck full, right? So total it is a 300 item, and how many items left? So 50 item left, because we have the one extra truck, we have the one extra truck, so that we can fill in that truck. So now there is no remaining unit book, no remaining truck. On the next day, random number is 80, corresponding number of booking will become the 450. Previous day remaining is 0, so total number of booking will become the 450. Number of truck is equal to, for the number of truck, random number we are taking the 45. So number of truck available will become 4. So 4 will be the fully filled by the 400 item. Now there is no available of truck. There is no available of truck. So remaining 50 units, remaining 50 unit you have to store over the night. Remaining 50 units you have to store over the night. Then for the third day, random number will be the 0.50. So total number of booking will be the 450. Previous day booking 50. So total number of third day booking will become the 500. Now number of truck, so it is the 74. So total number of truck will become the 6. So in the 6 truck, 5 are the fully filled by the 500 item, and one with the, right, one truck will be the unavailable, available. One truck will available which will go back. There is no use of that truck. 6 trucks are available, but you have the use of only the 5 trucks. For the fourth day, here we have the booking of the 450 item, right? No previous day booking, so total will be become the 450. For the number of truck, we are taking the number 0.77. So total 6 trucks are available. So 4 are fully filled. 4 are fully filled with the 400 items. one is partially filled with the 50 items, and one truck will be the unused. One truck is unused, right? So in this way, we can simulate for the 10 days. So over the 10 days, total number of booking will be the 4250. Total number of previous day units are 200. So total number of units we are transporting is the 4450. Total number of truck available will be the 41, right? Fully filled truck capacity will be the 4100, and this will be the partially filled capacity, and this much truck we have not used, and this much will be the item which we have stored over the night. So from here if you compute the different type of the averages, so average daily booking, so 4250 divided by 10, average number of truck 51 by 10, average number of truck not used 7 by 10, average number of trucks fully used 41 by 10, right? So average number of truck fully used, it is a 41 by 10. Then average number of unit stored overnight, so that is the 20 units. So on an average 20 units we are storing. So without actual booking, physical booking, without physical truck, we have simulated for the 10 days using the random number. That is the beauty of the simulation. Means now you can play the ludo without a die. Just using the random number table you can play a ludo. Clear? So that's all for today. Next class is very very important. Next class I will demonstrate how to simulate the queuing system, queuing process. Anything you want to ask? Anyone? In reading the table, in simulating?
Excuse me, sir.
Yes.
Sir, our midterm recheck's done.
Today it will be done.
Okay, sir.
By evening today it will be done. Any other doubt? So here and now I'm stopping the recording.